Hello guys, so today I'm going to explain you how can we solve this problem from Leetcode. The problem name is find the longest awesome string substring. So basically we are given a string s and an awesome substring is a non-empty substring of s such that we can make any number of swaps in order to make this palindrome. Basically the substring that we choose, we could make any number of swaps and make it palindrome. So if there exists such a substring, that substring would be called as the awesome substring. We need to return the maximum length of any awesome substring that we can find in this given string as. So for example, if we consider this string as that is 3242415, the largest I mean there can be multiple such awesome substring, but one of the string is this one 24241, and similarly this one would also be a valid answer, that is 32424, because we could make certain swaps and this can be converted into 24342 or 42324, as you can make this one a palindrome with some swaps. This one, as you can see, it can be made converted into this one. Here we can never make a palindrome more for for any given substring we can never make a palindrome for length greater than 1. So the maximum answer is 1. We could always one single digit is always a palindrome in itself. Here the whole string can be converted into palindrome, and yeah, of course this one is itself palindrome. So let's try to understand that what makes this substring a palindromic substring, or what we can say that an awesome substring. So we are given that there we can make any number of swaps for a given substring. So for example, I have listed down few basically, let's say these are the strings, and whether we can make these strings into a palindrome by making any number of swaps or not. So when we have said that we can make infinite number of swap, that means we can make any possible permutation out of these strings. So now we are free to arrange this in any possible order, and we would always try to arrange this in such order that we can make a palindrome. So for any given string to for that string to be a palindrome, it has to be divided into two equal parts, and there can be a string of at max one length in between these two equal parts. All right, so that means if any letter which exists here should also exist in this part as well. That means for all these digits in this, if we are only considering the strings with the numerical digits, then all these digits has to be even in counts, right? except one digit in the given whole string. So for example, in this case, if we see all of these are, one has two occurrences, 2 has also 2 occurrences, and 3 also has 2 occurrences. So we can definitely convert this into a palindrome by placing 1 2 3 and then placing 3 2 1 on the other half, and there is no string in between. For this case we can make, if we see, we have exactly this is the same as this one. For this case, if we see, we have 4 2s and 1 1. So what we can do, we can place 2 2s here, 2 2 here, and we can place single 1 here. And if we consider this one, there are actually 2 2s, 2 1s, but we will have 2 such numbers or digits which are occurring odd number of time. So this cannot be made into a palindrome. Similarly this one as well. So now we know that basically we need to find find the largest substring in which there is at max only one digit which occurs odd number of time, and all of the rest should occur even number of time. All right, so let's say now how we can solve this. Alright, so I am taking this example from the given problem, this particular example only. So In these problems where we are supposed to find the largest subarray or largest substring or smallest substring, the general approach that we use is to use the prefix array or prefix substring based approach, and this is what we are going to do here. So basically, what are we going to do? We need to keep track of the count or the parity of each element, like how many times it has occurred. So if we were able to find the parity till here and parity till here as well, then there has to be a way which will let us know what is the parity of all the elements within this part. So how can we find that? So let's see. So first of all, first thing first, that we want to keep track of all the frequency of each number. So basically, one way is to keep an array or a map of 10 elements where we would keep this count of each number individually. But yeah, that is very complex and will be very space consuming as well to go in this way. The other approach that we can follow here is to use bit masking approach, as we know that these elements can be as max 10 elements, 0 till 9. So we can keep a mask, and whenever we see an element for the first time, then we will change the parity of that bit in the mask. So basically our mask would be representing, so let me just choose one pen first. So initially our mask would be represented by all 0 instead. Yeah, 0 0 0 0 0. I will say 3 4 5 6 7 8 9 and 1 10. All right, 4 5 6 7 8 9 10. Yeah, so all of these are representing that how many times we have not how many times, but I'll tell you in a moment that whether this element is occurring even number of time or odd number of times. So 0 means we haven't considered any element till now. Now if we consider 3, so we should go to the third position and starting from 0 1 2 3. So 3 in that case it should be, yeah, we should go to the third position, that means here, and we should flip this one to 1. Now we go to the second one, and second one, that means this one, so we will flip this one as well. Now when we reach to the fourth, we will see that there is no element previously for 4 as well, so we will flip this one as well. Now we come to 2. Now when we come to 2, we see that 2 is already 1. That means till here there is one subarray whose till here there was this subarray or substring or prefix which contains 2 odd number of times. So what we need to do, we need to maintain this parity here. So what we will do, we will flip this one to 0. All right, so till here now this mask represents that there are 2 elements which are 3 and 4 which are occurring odd number of time, and rest of them are occurring even number of times. So this is what our mask represents, a status of prefix sum or prefix subarray. All right, so if we go for 4 now, then what will happen, then it will see that 4 was already 1, so it will flip it to 0. Then it will come to 1. So if this was one of the mask status, then we could see that there is only one element which is having odd frequency. So this could potentially be our answer, 32424. Yeah, this is also one of the potential answers. All right, similarly, once we'll keep on traversing through the end of the string, and we'll see that we can change this one to 1, and then we can also change this one, I think 3 4 5, this one to 1 as well. So this will be the end of the mask. So now that we know how can we find the status of all these frequencies of each numbers at any moment, how can we utilize this particular information to find the largest subarray? So I keep on saying this largest subarray, but actually it is largest substring. But yeah, don't be confused. It is fine. I mean, there is no problem as long as you are following the approach. So yeah, what I'm saying here is how can we use this information to find out the largest subarray, because this is something which is giving us the largest prefix. But if you remember the problem where we need to find out the largest subarray sum largest subarray whose sum is equals to 0 or a particular sum, then what we do is we subtract this current prefix sum with some previously calculated prefix sum. Here, how are we going to use the previously calculated prefix mask, I would say. So if you take a look here, then each of these masks represents status at any moment. So what we need to find, we need to find a subarray which has this particular quality, that a particular property, that all of its bits are 0, or at max 1 should be set to be 1 or turned on. All right. In other words, what I mean is, if there is a mask which represents the status of this part instead of prefix part, then this mask should represent that all of these bits are set to be 0, because here we can see that all of them are occurring even number of times. So all of these bits should be set to be 0. And if there is a mask which represents this particular part, then this should be representing that all of these are 0 except the first bit from right. That means not the 0, but the first bit from the right is set to be 1 except all of them. Alright, so basically what we have is, we have a prefix mask at any moment I or j, and what we want to know is that a prefix subarray mask instead. But do we need to store the subarray mask? The answer is no, because we are only interested in finding out whether there existed such a subarray mask which follows the property that we are interested in, that is, all of the bits are either 0 or at max 1 bit is said to be 1. Alright, so how do we ensure that there existed such mask? So let's say if at any moment I there was this mask, the mask status is represented by m of I, and any moment previously the mask status is represented by m of j, then if these two are equal, then what does it mean? It means that this sub part, the subarray part, should actually show the status where all these masks, all these elements within this part are occurring even number of times. Why? Because consider that this part, if at any moment, if these two are equal, that means here these two are representing the number of times any number, the parity of each number occurring. So if, let's say, there was such an element which occurred odd number of time here, then definitely this mask or this bit in this that particular bit in this particular mask would be different here, so it wouldn't be equal. Meaning, if all the elements within this part is occurring even number of times, that means all the mask at this moment and the mask at this moment should be equal. All right. So what we can do, we can just keep on storing the index of each mask, that what was the minimum index for each mask where it was occurring. So for example, if we knew that certain mask, let's say m, had occurred at index I, then because we are interested in finding the largest sum, so largest subarray, so if at any moment further we found the same mask again, then we would check from the previous most, because there could have been some other mask, some other index where the same mask occurred, but we want to find the largest, so we would find from the leftmost one, the first time where it occurred. So what we want to do, we want to store the index of each mask, the minimum index at which this particular mask has occurred, and then at any moment if we find the same mask again, then we would just subtract the length, like the index at which this is stored and the current index, and then we will find the length. That would this subtraction would give us the length. Then we would compare this length with the maximum answer that we have till now. So this gives us the answer for the case when we are only interested in the property where all of these are set to be 0, right? Because we just saw that mi equals to m of j only when all of them are even, and even means this parity of these bits are 0. All right. Now we saw that there can be a case when we want to have at max one bit equals to 1 as well. Alright, so let's see now how we can solve that particular property as well. So now we are talking about the second property. How can we solve the problem for the second property? And the second property is that we want to find a subarray which contains all these elements within it occurring even number of times, and exactly one element occurs odd number of times. And to find such subarray, now we know that we have certain mask at any moment index I is equals to m of I, and this represents that there are certain number of elements which have, let's say for example we consider this only, right? So this is telling you that there were such subarray, I mean there was this prefix subarray which contained 3 and 1 even number odd number of time and rest of them as even number of times. So if we try to one by one switch off or flip the bits here, so for example let's say if we flip this bit here, then what we get the exact same number as this one, and that means 0 0, and now this one is 1 0 0 0 1 0 1 0. All right, so this is some other mask that we'll find. And if we take a close look here, then if these two masks are occurring at two different indexes, then what is the property of the subarray that follows in between, and that falls in between these two indexes? The property here tells you that there exists a subarray which has all the even elements occurring even number of time except this element occurring odd number of time, because here also this was occurring one even number of time, and at the end also it is occurring even number of time. This odd number of time. This is also occurring odd, this is odd, and rest of them were occurring even, except this one bit is only flipped. This one bit is changed, meaning that this part from this index I to this index j, the subarray part, had only this particular element which occurred odd number of time, right? So this is what we will use to find out the answer for the second property. And the rest of the logic is similar to the property 1 that we use, that we will store the mask for each, I mean the minimum index for each mask, and we'll try to find the length of the segment, and then we'll compare it to the maximum answer that we have till now. So now let's move to the code, and I hope then it will be much more clearer that what are we trying to suggest here, or what the logic we have. Alright, so this is what our code looks like. So I have used map to keep track of the index, the minimum index of each mask. We can also use array or vector to store, because we know that the size of the mask can be as big as, the value of the mask can be as big as 1024, because because we have only 10 digits here, and yeah, the mask representing the 10 bits have maximum value as 1024. And yeah, and rest of the logic, let's talk about that. So once we don't have any, we haven't considered any index element from this array, we will store this one as -1. I have explained the logic of this prefix array in some other video. If you don't know about this, I would highly recommend first to watch that video to understand how this prefix sum or prefix array based logic works. Then I'll iterate over my string, and as we said that what are we going to do, we are going to flip the bit parity for each digit that we found at the current position. So the digit at this position is si -0. This gives the value which is currently at this particular index. Then once we do the XOR with one left shift here with this number, this is basically nothing but it's setting that particular bit to be off if it is turned on already, or vice versa. So now that we know the current mask at this moment, and if we see that this mask is already stored somewhere previously, that means we have found a subarray for which in which this particular subarray has all the elements within it as occurring even number of time. then we will compare this mask, compare this particular length of the segment with the maximum answer that we have till now. And this is the first property that we were talking about. Then we also need to consider the second property. Then how do we find the second property? What we said, that we wanted to flip one bit one by one from the current mask, and we see if this particular new mask occurs previously somewhere or not. So that's what I'm doing here. I'm now flipping one bit one by one here, each bit from 0 till 9. Then I'll create new mask, and then I'll check for the new mask same, and then the similar logic is here again. If this mask is occurring previously, then we'll compare the answer here with the length of the current mask, the length of the segment, current segment. And we also said that if this we want to store only the we want to record only the minimum index. That means we only want to store it for the first only for the first time when it is occurring. If this is already there in the mask in the map, then we don't want to store again, otherwise it will override and will not get the longest substring. So yeah, in the end I'm just returning the answer. I hope I was able to explain you guys properly the logic of the prefix and the logic of the bit masking here. So yeah, if there is any doubt or anything unclear, please let me know in the comment section, or any feedback for me. So yeah, I hope I was able to help. Thanks.